distance is given. So k divided by s of s plus 3, s square plus 3s plus 4.5. So first step you already know, to find poles and zeros. So pole s term s equals to 0, s plus 3, s equals to minus 3. Then for this we will get two roots, s is equals to minus 1.5 plus j 1.5 and s is equals to minus 1.5 minus 1.5 j, right. S is equals to minus 1.5 plus 1.5 j minus 1.5 minus j 1.5. Okay, now zeros, there is no s term, so s equals to 0. So this is first step. So similarly second is whether p is greater than z or z is greater than p. Yes, we are having 4 poles and there is no 0. So which one will be greater? That many number of n, right? So n is the branches. So in the root locus graph you will be having 4 branches. Okay. So third is p minus z. So p is 4 minus 0 equals to 4. So this 4 is nothing but q here. So next step is, fourth step is asymptote. Asymptotes formula is theta is equals to 2q plus 1 into 180 whole divided by p minus z. So for q is equals to 0, what is the value of theta? For q is equals to 1, what is the value of theta? Q is equals to 2, what is the value of theta? Q is equals to 3, what is the value of theta? So this I will mention as theta 1, theta 2, theta 3 and theta 4. So you will get 45, 135, 225, 315. Theta will be in terms of degree. So after asymptote, next step is centroid. Summation of real number of poles minus summation of real number of zeros whole divided by p minus z. So 0 minus 3, you can see here 0 minus 3. So consider real numbers. For this pole real number is minus 1, j is imaginary. Here also minus 1.5. So minus 1.5 minus 1.5 2 times, as we are having 2 poles, minus there is no 0, p minus z is 4. So you will get minus 1.5. So we'll draw the diagram. So zeros, that is s equals 0 minus 3 minus 1.5 plus j minus 1.5 minus j. So I will mark it here. S equals to 0 minus 3 minus 1.5 plus j 1.5 minus j 1.5. Okay, so this is clear. 0 minus 3 minus 1.5 plus j 1.5 minus 1.5 minus 1.5, right? So 4 poles. Now to draw the next step is to draw the root locus. From the right hand side, this is first one, so root locus will exist till another pole or 0 come in the middle, it will exist. So this is RL, this is NRL. NRL means no root locus, right? Now centroid is 1.5, right? Centroid we got is 1.5. Then we need to draw the angles. So centroid I had marked down 1.5. I'll mention it. Centroid 1.5. Then I will draw the angles 45, 135. So this is 45, theta 1, theta 2, 135, 225, 315. Right. So next is breakaway point. Breakaway point, whether breakaway point is existing, yes, with respect to the prediction, two adjacent poles are there, in that root locus is existing, so we can predict that here we can have a breakaway point. So we'll solve breakaway point, that is 1 plus g of s into h of s equals to 0. So breakaway point, I told to remember dk by ds. Right, 1 plus g of s into h of s is already given, k s of s plus 3 s square plus 3s plus 4.5. Right, so if you solve that, then you will get s raised to 4 plus 6s cube plus 13.5 s square plus 13.5 s plus k equals to 0. Then I told to remember dk by ds. So take k on one side, other term on the other side, minus s raised to 4 minus 6 s cube minus 13.5 s square minus 13.5 s. Right, now differentiate it. So as I told, breakaway point means remember dk by ds. So k, take k on one side, then differentiate it. So minus 4 s cube minus 18 s square minus 27 s minus 13.5. Now if you put this in your calculator equation, then you will get 3 roots. Cube, no, so 3 roots, minus 1.5 s equals to minus 1.5, s is equals to minus 1.5. So for this s, what is the value of k? For this s, what is the value of k? What is the value of k? So yes, you put it here, you will get the value. So k, you will get positive for all the 3. So this s is selected. So this is breakaway point. This intersection with imaginary axis. So we got this equation 1 plus g of s into h of s. If you solve, you will get this characteristics equation, you will get. So take that characteristic equation, form the root array. So for intersection, we will form the root array. So 6 into 13.5 minus 13.5 divided by 6, you will get 11.25. If you want, I will solve here. 6 into 13.5 minus 13.5 divided by 6. So again 6 into k, 6k minus 0 divided by 6. So 6 will get cancelled, you will get only the remaining will be k. Right. Similarly 11.25 into 13.5, you will get 115.87 minus 6k divided by 11.25. Okay, so here also you will get 0 as there is no term. 11.5 into no term 0 minus 0 into no term means 0 into 6 0. So again this I will consider it as a into k, ak minus 0 divided by, again this whole term I consider as a, so a will get cancelled, only k will remain. So in this root array only unsolved equation is this one. So take that equals to 0 for solve for k. Okay, then above this unsolved equation we will be having auxiliary equation. Above unsolved equation we will be having auxiliary equation. Take that 11s square. If here it is s square, then here it will be s raised to 0. Okay, for example, if here it is s raised to 4 term, right, then here it will be s raised to 2, here s raised to 0. Similarly here s raised to cube is there, then here it will be s raised to 1. Okay, similarly Auxiliary equation 11.2 s square plus s raised to 0. S raised to 0 is 1. Right? So 11.25 s square is equals to k, introduce k, minus 25.3. So solve for s, we will get plus or minus j 1.5. This is intersection with imaginary axis. This angle of departure. So angle of departure will exist only when complex root is there in the problem. Okay. So complex root, if it is existing in the denominator, then we should solve angle of departure. Pi d is equals to 180 minus pi. If complex root, if it is existing in the 0, then angle of arrival pi a is equals to 180 plus pi. Only sign will change. Okay. So you know the formula, pi d is equals to 180 minus pi, summation of pi is equals to summation of pi p minus summation of pi z. Summation of pi p means pi p1, pi p2. How many poles are there in a problem? All poles. Summation of pi z is equals to pi z1, pi z2. So how many zeros are there? All the zeros. So I had redrawn the diagram. So we should draw diagram separately for angle of departure. So we are having 4 poles. So angle of departure means complex root. When complex root is there in the denominator, minus 1.5 plus j 1.5, minus 1.5 minus j 1.5. So consider positive one, so it will be easy to calculate. So I am considering this as pi d. So this pole, complex root means this, I am taking this as pi d. So from this I will mark to each pole and 0. Right, then we need to find the angles, pi p1, pi p2, pi p3. You can take vice versa also like pi p1, pi p2, pi p3 also. Now this you can see, pi p2 directly will come to know that it is 90 degree. Right, similarly here, in order to find pi p3, formula is tan inverse of opposite by adjacent. See here, so in between these two we need to find angle. So in the middle we'll draw one line in between these two line which shows opposite. So opposite, how much it is? Measure 1.5. This is opposite. Right, then this is adjacent. So how much it is? Measure it. Again 1.5. So tan inverse 1.5 by 1.5, that is 1. You will get 45 degree. Right, similarly pi p2 is equals to, here we can say it is 90. So I will write 90 degree plus we need to find angle for this. So in between these two I'll draw our line middle which shows opposite. Again measure it 1.5, adjacent also 1.5. So tan inverse of 1.5 by 1.5, so 90 plus 45, which is equals to 135. Correct, no? So pi summation of pi p means 90 plus pi p2 is 90, pi p3 we got 45, pi p2, sorry, this is pi p1, no? 90, this 90 plus tan inverse of this, so that is 135. So 90 plus 45 plus, so 90 plus 45, 135, 270. So there is no summation of pi z, 0. So this plus this will get summation of pi p minus summation of pi z. So here we will get 270. So 180, that 180 here, minus pi is 270, which is equals to minus 90 degree. So pi d, you can see here, I consider this as pi d, minus 90 means this straight line. This is minus 90. Now breakaway point is also minus 1.5 here. So from breakaway point it will intersect the imaginary axis and it will move with respect to asymptote here also. So 1, 2, 3, 4. So n is equals to 4. So this is the actual root locus.